Today we're going to talk about the Pythagorean Theorem and its converse. This is section 8.1 in the Pearson geometry book. So this is probably a theorem that most of you are comfortable with or used to or you've seen before. The Pythagorean Theorem is a squared plus b squared equals c squared. And any time you have a right triangle and you have two of the sides, any two sides, you can always find the third side using the Pythagorean Theorem. That's the beauty of this. All right, it says the Pythagorean Theorem can be used to find the length of a side of a right triangle. A and B are the legs of the right triangle, and C is the hypotenuse. And they give an example here. What is the value of G? Leave your answer in simplest radical form. And that's something we're going to show in practice here also, simplest radical form, because I know that that's something that some of you are struggling with. Using the Pythagorean Theorem, substitute G and 9 for the legs and 13 for the hypotenuse. So we're substituting these in and saying g squared plus 9 squared equals 13 squared. G squared then plus 81 equals 169. Subtract 81 from 169, and you get that g squared equals 88. To undo a square, you take the square root of both sides. So g equals the square root of 88, and we can break that down. 88 is 4 times 22, and 4 is a perfect square. So 4 is 2 times 2, so that pair of 2's can come out front as a 2, and 22 stays home. So you end up with g being 2 times the square root of 22, or 2 root 22. All right, so let's practice that here on a few exercises. This says to identify the values of a, b, and c. I write question mark for unknown values, then find the missing side lengths, okay? I'm just going to put c in place here because a and b are the sides. And the same thing here. It looks like we're looking for the hypotenuse on both of these. So here I have 4 squared. Oops. Oh, I need to go to freehand to write. Okay. Here I have 4 squared plus 8 squared. Those are a and b equals c squared. And then we're just simplifying. 4 squared is 16. 8 squared is 64 equals c squared. 16 plus 64 is 80 equals c squared. So to undo a square, we take the square root of both sides. So c equals the square root of 80. And a square root of 80 does break down. I'm going to show this over here to the side. The square root of 80. We're simplifying this. We can see that 80 is, in fact, you can break this down any way you want to. If I could start with 8 times 10. Okay. 10 is 5 times 2. 8 is 4 times 2. And then 4 is 2 times 2. So my bottom level prime factorization is 2 times 2 times 2 times 2 times 5. So I'm going to pair them up. I have a pair of 2's here. And I have a pair of 2's here. My pairs come out front. So there's one of my pairs, and here's the other pair. Okay, and then 5 doesn't have a date, so he has to stay home. So when I'm simplifying this the rest of the way, 2 times 2 is 4, root 5. Okay, so I see that the square root of 80 simplifies to 4 root 5. There is my simplest radical form as requested in the instructions. Okay. All right. I took that 5 a little far. So for number 2, I have 7 squared. This looks terrible. 7 squared plus 7 squared. These are my a and my b because they are the legs of the right triangle. Equals c squared. Okay. So 7 squared is 49 plus 49, and I really wish I could type squared. 49 plus 49 equals c squared, okay? And then I know that 49 plus 49, 80, 98, yep, equals c squared. I'm going to put my squared in just a minute. Okay, go back to freehand. I'd like to type when I can because this pen, I think the little tip needs to be changed. This is c squared. This is c squared. So I undo a square by taking the square root of both sides. So the square root of 98 is c. Okay. So I'm going to show this process a little bit further up here just to give myself a little more space. The square root of 98. And I can see that it is a even number, so I can break this down by dividing it by 2. Okay. So 98 is 2 times 49. Oh, 49 is a perfect square. Isn't that nice? Okay. I can see that 49 is a perfect square of 7. So that helps me out here. And you may have already seen this. 49 plus 49 is the same as saying 2 times 49. So my bottom line prime factorization here is 7 times 7 times 2. I have a pair of 7s. And then 2 has to stay home. So I can see that root 98 reduces to 7 times the square root of 2, or 7 root 2. Okay? And that's actually a precursor to our special right triangles, which is coming up in section 8-2. I'm going to switch this to black real quick so that I can circle these answers. I'm going to try to do this with my actual keypad because the pen is sketchy today. So I can see that my final answer here was 4 root 5. Okay, my final answer here was 7 root 2. Please make sure that you are actually watching these and not fast forwarding or watching these at a greater speed, because going through the process is actually the point here. It's actually the purpose of going through these videos is so that you understand how to do them. Not just so that you get the answers. The answers are totally and completely meaningless if you don't understand how to get to them. The process is what matters here. All right, so on number 3 and 4, we're just practicing more of exactly what we just did in 1 and 2. Okay, I'm going to bring this up closer to the top of the screen, so hopefully my pen will work a little bit better. Okay, so let me try a different color. Maybe the pen will like a different color. I know that doesn't make any sense. Okay, so on 3, here I have the hypotenuse, which is 10, and A and B are the sides, or the legs. So 6 can be A. Actually, I'll make this A, because 6 and B look so similar. And then here, again, I have the hypotenuse here, and I have one of the legs, so I'll put A in there. Okay, so for 3, I have A squared plus B squared equals C squared, which would be A squared plus 6 squared equals 10 squared. It does work a little bit better when it's up closer to the top of the screen. Okay, so simplifying here, I have A squared plus 36 equals 100. My next step then would be to subtract 36 from both sides. Subtract 36. And I get that A squared equals 64. Oh, that's a 4. So taking the square root of both sides, I get that A is the square root of 64, which is, of course, 8. So that tells me my missing leg up here is 8. And that is a Pythagorean triple that we will talk about soon, I presume. Okay, so on 45, I have A squared plus B squared equals C squared, or A squared plus 3 squared equals the square root of 45, which is the hypotenuse, and squared. Okay. Note here that you have a square root squared, and since those are opposite operations, then the symbols just come off here. So I have A squared plus 3 squared is 9. The square root squared, those come off, and I just end up with 45 here. Okay, so I'm subtracting 9 from both sides. Okay, so if I think about this process through with number sense, cross those out. I have a squared on the left. 45 minus 9. Well, I can think of this as 45 minus 10, which would be 35. But oops, I took away one too many. So it's actually 36. Put that one back. Okay? So undoing a square is taking the square root. So a equals the square root of 36, which is, of course, 6. So I can see here that 6 is my missing side. So there are a couple of really good examples of Pythagorean theorem. Okay, so let's see what it says here on 5. A square has a side length that is 9. What is the length of the longest line segment that can be drawn between any 2 points of the square? Okay, so let's see. I don't want an image. I want a square. Rectangle? Okay, can I draw a rectangle here? Oh, look at that. I'll make it look as much like a square as I can. And I don't need it filled. No fill. Okay. All right. Oops, delete that. Can I delete that? Okay. All right, so I'm going to go back to my freehand here, or I can actually draw a line in here. If the square has side lengths of 9, that means that it's a square. All of them are the same. So this is 9 inches. I'm going to put the little 2 tick marks there to show this is inches. Every one of these sides is 9 because this is a square. 9 inches here. And I can also show that all 4 of my angles are right angles. Okay. I can show that in all of them, maybe. Okay. And it says, what is the length of the longest line segment that can be drawn between any 2 points of the square? Well, hopefully you recognize that a diagonal is such line segment. So we're going to draw a diagonal in here. And I'm going to try to make a line work inside the triangle so that or inside the square so that we can see an actual perfect-ish line. Okay. That work? It does work pretty well. Okay. All right. So this is what is the length of the longest line segment. So that's what I'm trying to find out is the length of that line. So I'm going to put, actually I'll put C here because I'm now going to be looking at the right triangle that has been created inside there. So I'm going to change this to blue. Okay. So I am now looking at this right triangle. Okay. I've got a squared, b squared, c squared. Okay. So I'm going to be looking at the Pythagorean theorem here. A squared plus b squared here is 9 squared plus 9 squared equals c squared. I'm trying to find the length of this diagonal. We will know how to do this much faster after we do section 8.2. But for right now, let's just go ahead and finish the math here. 9 squared is 81. 9 squared is 81. 81 plus 81 equals c squared. Okay. 81 plus 81, 162. 162 equals c squared. Maybe I'll appreciate the step-by-step process here. It's a little painful. So undoing a square by taking the square root of both sides, so c equals the square root of 162, which of course can be simplified. It's an even number. Okay. So we're going to simplify this. Okay. I'll show this off to the side here. The square root of 162. Ooh, that's ugly. $162. Okay, now we did 81 plus 81 to get 162. Good grief, that's terrible. So 162 is 81 times 2. We know that. So we know this is going to break down to 2 times 81. That's how we got it to begin with. Okay, and we know that 81 is 9 times 9. That's how we got it to begin with. Okay. Now you can break each of these 9s down to 3 times 3, 3 times 3, or you can just save yourself a little time here and say, oh, I've already got a pair of 9s right here. So the pair of 9s is going to come out front of the root. Okay, and the 2 doesn't have a date, so it's got to stay home. So I end up with 9 root 2. Okay. Go ahead and switch this color over so that I can see that answer a little bit better. 9 root 2. Okay. All right, now looking at 6, right triangle ABC has legs of length 4 and 7. What is the length of the triangle's hypotenuse? We could just go ahead and go straight to Pythagorean theorem here. If we know the legs are 4 and 7, we know that's where A and B are going to be. So I'm going to move this up, so I hope my pen might work a little bit better. Okay, go ahead and save this so I don't lose anything. Okay, so if the legs are 4 and 7, then I'm starting with 4 squared. It's not working any better. Plus 7 squared equals c squared. Tell you what, I'm going to write my equals c squared in a couple of times here, and then I'm going to type. Because if I don't need to write that exponent, then I think that I can make this a little bit quicker. I think that's how many steps I'm going to need. Okay, so let's go to text. 4 squared is 16. Plus 7 squared is 49. Okay. 16 plus 49. Oh, this is 40 and 10 is 50. 65? 65. Okay. So then we know that we take the square root of both sides to undo that square. So I've got square root of 65. Okay. And I'm going to see if I can break that down any. I'll do this over to the side here. Square root of 65. Okay. Well, it ends in a 5, so I know it's divisible by 5. Okay. It'll be 5 times, well, 60 divided by 5 is 12, so 13. I think that's right. Okay. 13 and 5 are both prime numbers, so this actually cannot be broken down further. So it turns out that root 65 is as simple as it gets. Switching to black, and I'm just going to go ahead and circle my root 65 because that's it. And I actually didn't need this last c equals anyway. Okay. All right. For 7, televisions are sold by the length of the diagonal across the screen. If a new 48-inch screen is 42 inches wide, how tall is the screen? Tall of the screen being the diagonal. Okay. Oh wait, 48 is the diagonal. Sorry. Televisions are sold by the length of the diagonal. So if it's sold as a 48-inch television, then that is the length of the diagonal. So let's go ahead and make ourselves a rectangle here, because that's what we're going to be looking at. There's our television. Does that look about like a television? We're going to say it's a television. Okay. All right. So we're going to say that, let's go ahead and make ourselves a line. Line going from corner to corner. There's our diagonal, and that is how the televisions are sold. Did y'all already know that? You might have already known that. Okay, so the televisions are sold by how long the screen is. So this is 48, or the diagonal of the screen, that's a 48-inch diagonal. And it says that the screen is 42 inches wide. 42 inches wide. So we want to know how, put that in the wrong place. 42 inches. We want to know how tall the screen is to the nearest inch. So we're going to call that x. Or we can call it a. You can call it whatever variable you want to. So we need to set up our Pythagorean theorem here. We're going to have a squared, I'll put my squares in just a minute, plus 42 squared equals 48 squared, because our hypotenuse goes on the end. Okay, so I'm going to switch over to freehand and draw in my squareds here. Someday I'm going to learn how to make squareds in here without using this pen. Or someday I'll get a better pen. Okay. All right. So we're going to need to simplify here, obviously. Oops, excuse me. I hit the wrong thing on my phone. Okay, 42 times 42. So I've got a squared plus, and I'm going to switch over to text because I now have actual numbers. A squared plus 42 squared is 1,764. That equals 48 squared. 48 times 48 equals 2,304. So our next step then would be to subtract 1764 from both sides. Subtract 1764, okay? And then I end up with, let me draw a line here. That cancels out. And I end up with a squared equals, and we're doing the math. 2304 minus 1764 gives me 540. Okay, 540. All right, so then I know that if I take the square root of both sides, and I want to actually draw that a little bit better because that looks like a 1. I hope that y'all know that that's not a to the first power. That's actually a squared here. Okay. Okay. So then when we take the square root of both sides, I've got that a equals the square root of 540. And we're going to need to break that down. Okay, let's put my square root symbol in here. Let's see if we can break that down. I can't take that screen up anymore. Okay, so the square root of 540. Well, it's an even number, so I know it's divisible by 2. And a calculator may come in handy here too. 2. Actually, I know it's divisible by 10. Why don't we do that? It ends in a 0, so it's divisible by 10. It's going to be 10 times 54. That'll help. 10 times 54. 54, that's a familiar number. That is a familiar multiple. 54 is 9 times 6. Okay. Okay. So I'm going to put my legs here and see if I can type some numbers here. Make it look a little bit better here. Okay. So I've got 9 times 6, and then 10 is 2 times 5. Okay. Need to put some more legs in here because I know that the 9 breaks down and the 6 breaks down. 2 is prime, 5 is prime. Okay. 9 is 3 times 3, and those are both primes, thank goodness. And then 6 is 3 times 2, which are, oops, that should be 2, which are both prime. Okay. So we now have our bottom line prime factorization. 3 times 3 times 3 times 2 times 2 times 5. Okay, so we need to circle our pairs. Find me a color for this. What have we not used? I don't know that I've used this blue. Okay, so I have a pair of 3s here. I have a pair of 2s here. And then I have a 3 and a 5 that have to stay home. Okay, so I have the 3 coming out front on a date, and then I have a 2 coming out front on a date. And then I have a 3 and a 5 staying home. If you are bad lost on this process and you have watched these videos slowly and carefully, and the other video that I sent out, please email me. I don't know that you're bad lost unless you tell me. I have a couple of students who email me regularly, and I'm able to help them. And we've even set up some separate calls. You too can do that if you will let me know, okay? All right, so after we simplify this, A equals 3 times 2 is 6, of course. And then we have a square root symbol, which I'll draw in just a second. And then 3 times 5 is 15. So that's as far as you can take that one. Get my symbol back here. And this brings us to our next example. Okay? All right. So this says, using theorems 8.3 and 8.4 to determine whether a triangle is acute or obtuse. Let A and B represent the shorter sides of a triangle, and C represent the longer side. If a squared plus b squared ends up being greater than c squared, then the triangle is acute. Okay? If a squared plus b squared ends up being less than c squared, then the triangle is obtuse. And then, of course, if a squared plus b squared is equal to c squared, then the triangle is right. Let's add that here because I want to make sure that that's clear to everybody here. Okay? So if a squared, I'll put the squareds in a minute, plus b squared equals c squared, then the triangle is right. Okay? Make sure that we understand that. If the Pythagorean theorem works, then it's a right triangle. That's a squared. This is a squared. And this is a squared here. I guess I could type 2's there. I don't know if I could or not. I could try. All right, so we're going to be testing this here. Here's an example here. Okay, so we have A, B, and C. We know that C represents the hypotenuse, and it's always going to be the longest side. So 11 is C, and then A and B are the other two. So A squared plus B squared is 6 squared plus 8 squared here. Well, 6 squared is 36, and 8 squared is 64. And 36 plus 64 is 100. So A squared plus B squared is 100. C squared is 11 squared, which is 121. Since 100 is less than 121, then the triangle is obtuse. And I would keep this handy down here. If A squared plus B squared is less than C squared, then the triangle is obtuse, just so you don't forget. Basically, whatever C squared ends up being kind of drives it. Here, since C squared is bigger, that means it's obtuse. Obtuse is the bigger angle. Since C squared is smaller here, then it's acute, because acute is the smaller angle. And then, of course, if they're equal, it's right. We know that. Okay? So here, we're going to be squaring each one of these and determining what's what. Okay? So, I wonder if I can put little 2's in here to indicate that I'm squaring them. Let me try that. That might work. Give myself a little bit smaller font here. Can I put a 2 here to show this is going to be squared? How cute. Okay. So I'm going to square each one of these. So that way I don't have to try to write with this pen and confuse everybody. Right now I'm just putting the squareds in here to show that I'm going to have 7 squared, 9 squared, 10 squared, 18 squared. I'm going to square everything on here. Squared, squared. I'm squaring this whole thing, and I'll put parentheses around that in just a minute. But while I have the font so tiny, I want to finish putting my 2's in here. Okay, and I'll put some 2's in here. By the way, some of you that are in the virtual class, I've continually asked, how do I show work? This is how you show work. Pull it into PDF Escape like I'm doing in my videos. And you can see how I'm showing work all over the place here. That's what you should be doing on your homework. Face-to-face kiddos, these notes are your homework. Okay. So we just need to do a bunch of math here. Those ones that are like 7 root 3 squared, 14 squared, we'll look at how to tackle those in just a minute, okay? I'm going to go back to the regular, was it 12 font? I think it was 12 font. And put some parentheses in here. Maybe a little bit sooner. I don't know if I can now that I've started that. There we go. I'm going to be squaring the entire thing here. That's what I'm showing here with these parentheses. This 7 root 3, I'm squaring the whole thing. I'm squaring 7 and I'm squaring root 3. Same thing here, same thing for this 10 root 2. Okay? All right, so now I can just do the math here. Okay? Now my 2 smaller ones are my a squared plus b squared. Okay? So 7 squared is 49. And 9 squared is 81. And then I have 10 squared over here, which is 100. And I need to compare those. Okay, so 49 plus 81. Well, if I take this 1 and move it over here, then I've got 50 plus 80. 50 plus 80 is 130. And then I have 100 over here. Well, I can see that 100 or 130 is greater than 100. So my a squared plus b squared is greater than, which means the c squared is less than, which makes it acute. Okay? So this one is acute. Okay. All right, so let's continue with that. 18 squared, 16 squared, 24 squared. I do not know these off the top of my head, so I am going to use my calculator. 18 squared is 324. I'm adding that to 16 squared. I should know that one off the top of my head, and I do. It's 256. 256. Okay, and then I'm going to square 24, which I do not know off the top of my head. That's 576. 576. And I'm adding these together. So I've got 324 plus 256, and that's 580. Ooh, it's not much bigger, but it is bigger. 580, and then 576. I'll take my pen here and show that I know that 580 is, even though it's just a tiny bit, it is bigger than 576. So since it's bigger, that means that c squared is smaller, which again makes this one an acute triangle. A-C-U-T-E. Okay. Continuing with this, 3 squared is, of course, 9. 5 squared is, of course, 25. Okay, now when it comes to squaring 5 root 2, I'm squaring 5 squared, which is 25. And then I'm multiplying that by whatever root 2 squared is. Okay, well, root 2 squared, remember the square root and the squares cancel each other out, so it's just 2. Okay, so when I am simplifying further here, 9 plus 25 is 34. And then over here, 25 times 2 is 50. And now we can compare. Our a squared plus b squared is actually smaller this time. And our c squared, which is 50, is bigger. So since it's bigger, that means we have an obtuse triangle here. Obtuse. Okay? Continuing with our math here, we have 10 squared plus 10 squared, or 100 plus 100. And then we have, for our c squared, 10 squared, this is 100. And we're going to be multiplying that times root 2 squared, which is just 2. Okay? So 100 plus 100 is, of course, 200. And 100 times 2 is, of course, 200. So we could put an equal sign here. Okay, so since they are equal, what kind of triangle is this? Yes, this is a right triangle. When a squared plus b squared equals c squared, it is a right triangle. Okay, so for number 12 here, we have 8 squared, which is 64, plus 6 squared, which is 36. And then we have our c squared, which is 10.5 squared, which I also do not know off the top of my head, but that's okay. The calculator does. 10.5 times 10.5 is 110.25. And I can tell you right now, these aren't equal to each other. Okay, so 64 plus 36 is 100. 100. Not equal to 110.25. So I can take my freehand here and I can show the alligator eating the bigger one. I can see that the c squared is bigger there, and since the c squared is bigger, this is going to be an obtuse triangle. Obtuse. Okay, continuing. Okay, a squared plus b squared equals c squared. Here I have a squared, or 7 squared, which is 49, plus. And then I have 7 root 3 squared, which is going to be 49 times 3. And then my 14 squared is my c squared, which is 196. 196, excuse me. Okay, so 49 times 3. 49 times 3 is 147. So here I have 49 plus 147. And over here I have 196 still. Okay. 49 plus 147 is 196. What do you know? 196 actually equals 196. So I can see that this is a right triangle. Okay. All right, so 3 more of these. 22 squared is 484. Did not know that one off the top of my head. I know 13 squared, though. That's 169. Okay. And then 23 squared, which I also don't know off the top of my head. 23 times 23. Gives me 529. 529. Okay. So 484 plus 169 gives me a bigger number. 653 is going to be greater than 529. So I'm going to take my freehand in here and make the alligator eat the bigger one. And that shows me that the c squared portion, 529, is smaller, which makes this an acute triangle. Okay? 2 more. 17 is 289. Plus 19 times 19, 361. And then I have 26 squared. 26 times 26 is 676. 676. You're also not going to equal. I can tell that already, because 9 plus 1 does not equal 6, or anything that ends in a 6. So I have 289 plus 361, which gives me 650. They're not that far off, though. 650, and I'm comparing that to 676. So I'm taking my freehand here, and I'm making the alligator eat the bigger one. Alligator always eats the bigger one, because he's hungry. He's no dummy. Okay, so since the c squared portion is bigger, this one's going to be an obtuse triangle. Okay, and one more. 21 times 21 is 441. And then 28 times 28 is 784. Okay, and then I'm going to square 35, which I also feel like I should know off the top of my head, and I don't. That's 1,225. Okay. So I'm adding these together, 441 plus 784. Hey, it equals So I get 1,225 equals 1,225. So it's what kind of triangle? It's a right triangle. For some reason, I always want to see if they've balanced these. I have 3 right triangles here. And I have 3 obtuse and I have 3 acute. They did balance it. That doesn't matter. It's a mathy part of me, I guess. Okay, so for 17, it says a local park is in the shape of a triangle. It's being redesigned. The fencing around the park is made of 3 sections. The lengths of the sections of the fence are 27, 36, and 46. The designer of the park says the triangle is a right triangle. Is he correct? So what we need to do is find out if the 2 smallest numbers squared and added together equal the largest number squared and added together. So we want to know, is 27 squared, and I'll put the squareds in a minute, plus 36 squared, is that equal to 46 squared? That's the question, okay? Let me put the squareds in. And I'll just try to freehand that. Maybe the pen is behaving by now. Is 27 squared plus 36 squared, it's not really behaving, equals 46 squared. Let's do the math and find out. Okay, and I'm going to make sure that I wrote those numbers down right. I did. 27 times 27, that's 729. So I've got 729 here. And I'm adding that to 36 times 36, which is 1,296. And I want to see, does it equal 46 squared? 46 times 46 is bigger, 2,116. Okay, so I'm going to add those other two together, 729. Whoops, 729 plus 1,296. And that equals 2,025. And I'm going to put a slash through this in just a second. I'm going to put an equal sign up there too with a, no, I'm not. 2,116. Okay, so we can see that 2025 does not equal. That's what that looks like, an equal sign with a slash through it. 2116. So it's not a right triangle. Not a right triangle because the lengths do not work in the Pythagorean theorem. Okay, one more. Your neighbor's yard is in the shape of a triangle with those dimensions. What kind of triangle is it? So we're doing the exact same thing we did in 17. Okay, so we are going to say 85 squared plus 84 squared. And then over here we've got 120 squared. And I'll put my squareds in. And I'll do the math. Okay, 85 squared. This is the last time I'm going to ask you to work in this worksheet. Thank you. Okay, so let's do the math. 85 times 85. Big numbers here. We have 7,225. Okay, and then I've got 84 times 84, which is 7,056. Okay, and then I've got 120 squared. Oops. Which is 14,400. I don't think these are going to match. They are not going to match. Okay, so I'm going to add these up. 7,225 plus 7,056 ends up being 14,281. And then I'm comparing that to 14,400. So it's not a right triangle, but we need a symbol in here to tell us which one. Okay, so the alligator is going to eat the bigger one, which means the c-squared portion is bigger. And since the c-squared portion is bigger, then it is obtuse. Whew, we did it. We got through it. Okay. I hope this has been helpful, and I hope that you've taken the time to listen to this and not just written down answers, because they don't mean anything if they're just answers. Okay? All right.